Hi everyone, welcome to our fourth lecture that you've said that is going to base much on the storm force. Now, in our last lecture, in our lecture 3, we discussed about the subparticles of where we talked about how particles is being divided. We said that particles are divided into two. Basically, particles divided into force and also into matter. We said that matter can equivalently be called fermions and force is called bosons. Now we said that boson force is subdivided into gluon, we have gamma, we have Z, and then we have W, where we say that gluon is a charge carrier for the storm force. Now we also say that W is the charge carrier, or not really charge carrier, but force carrier for the weak force. And then we further said that the fermions are further divided into quarks and leptons. And then within the quarks, we say that there is a further division of quarks that is called hadrons. And the hadrons, we say that is nothing other than the nuclear, because it is a composition of the protons and the neutrons. Now, today we want to discuss about the storm force. And it is also good to also remember that we said that force are divided into four main types. We talked about the strong force, weak force, electromagnetic force, and we have the gravitational force. Now, the strong force is the force that allows up and down quarks to stay tightly together. It packs the upwards and downward quarks to stay together, making them to be protons. In other words, make protons to stay together as protons and neutrons to stay together as neutrons. So clearly it means that it is gluon, because we say that the strong force carrier is gluon. So it's the gluon carrier that binds the proton and neutrons together. It brings these protons and neutrons together. Now we say that this is realized because of the attraction between upward and downward quarks. That is what brings in that strong force of attraction that go against the force of gravitation, or not really gravitation, but electromagnetic force that we expect to be experienced within the same charge proton particles. Then we talked about the hadrons, and within the hadrons, we say that fundamentally there are three forces. In my view, there are three forces that are acting within the hadrons. Remember, we have said that there's gluon acting in the hadrons, and as gluon is acting on the hadrons to keep the nucleus together, we also have the pulsive electromagnetic force that is acting between the same positively charged protons that tries to repel these charges far apart. But this is superseded by the gluon, the force of gluon. And again, there's another force that is acting from the nuclear, which is called the nucleus force. It is acting from the hadron. And this is the force that now attracts the electrons to the hadrons. The electromagnetic force that attracts the electrons that orbits around the hadrons, itself, because within the hadrons we have the positively charged protons, and then in the outer shell we have the negative electrons. Now these, when they try to pull together, that force of attraction is what is experienced as a result of the electromagnetic force, and it's also called the binding energy or the nuclear energy. So we have three forces. that is acting within the hadron or within the nucleus, if you don't like to call it hadrons, within the nucleus. I've said that we have the electromagnetic force that acts between or we can say nuclear force, as much as it's also an electromagnetic force. Nuclear force of attraction, that is between the electrons and the hadron or the nucleus. And then we have the gluon. The gluon is the force that acts between the upward and downward quarks. In other words, it tries to glue the quarks together, make the quarks stay together within the strong force of repulsive electromagnetic force. Then we have the strong repulsive electromagnetic force. So that we have the strong repulsive force that is between protons, positive protons particles. Then we have the nuclear force of attraction, and then we have the gluon that glue them together. So to make it simpler, we can say that we have gluon, and then we have force of both attractive electromagnetic force and repulsive electromagnetic force. But then the repulsive electromagnetic force is superseded by the gluon, and therefore its effect is not being experienced because the gluon is stronger than the repulsive electromagnetic force within the two upward quarks and one downward quark. Now, gluon is the force carrier that holds the quarks to stay together. Again, it's that repulsive force. And that one tells us why it is a carrier for the strong force. It means that gluon or strong force carried by gluon is stronger than electromagnetic force. So we can appreciate that fact that is stronger than electromagnetic force, because if it is able to keep the repulsive or protons together and neutrons together, then it means it's very strong. It's not such a weak force, and that is why it is a strong force carrier. Then also in modern physics, there are some factors that we normally consider. Now, in modern physics, particles are normally assigned some properties such as energy. We assign them charge, like we have positive charge and negative charge. We assign them mass, we have the spin. And there is another property, color, that is sometimes less known to many. Now, the particle have a property called color. It is closely related to the strong force, as it influences the color change within the quarks. Now, this property is realized when the gluon oscillates, when it oscillates between upward and downward quark. Now, as they oscillate, it changes the fundamental property of each quark depending on the color attached to these quarks. Now, and as color changes, the more the quarks get more attached together. Now, what I mean is that, as you can see in this case here, as you can see in this case here, okay, as you can see in this case, we have our color influence there. You can see we have our colors. Now we can see gluon is attached to one upward quark. Now as it rotates, it will be changing the color property. As gluon rotates, as it oscillates from upward quark to downward quark. When it comes to downward quark, automatically this red color will move to the downward quark, and then this color here will come to this, and this color will go to this. So you can see it changed. It's changed the color property. Now, and as it changed the color property, then that one clearly tells us that that is, the more the gluon, the quarks get attracted together, and the more they go against the electromagnetic force. Now, when this behavior that we have just discussed here is presented graphically, then you can see we have an exponential kind of graph, where if we have the x-axis here to be our force of attraction or force of repulsive, and then we have the distance. Now you can see that within our graph, at 10 to negative 16 meters, you can see how at that point, remember that the distance is very small, and you can see how the repulsive force is very strong. It's very high. As you can see, there's a high repulsive force when they are close. And when you move far off the distance where we have now negative 10 raised to negative 15 meters, then you can see how the force of attraction is big. When you try to find the area under this graph, this force here is very strong as compared to this force. Now, this one now contradicts the electromagnetic force, where the closer the opposite charges are, the stronger the attraction, and the far they are, the weaker the attraction. In this case, the far they are, the stronger the attraction, and the closer they are, the weaker the attraction. And that can be evidenced by it can be scientifically evident by this graph here, where we have up there we have the repulsive, and then down here we have the attraction. Now, fundamentally, that this is what composed strong force, and how strong force influence the fundamental makeups of an atom. Now, in our next class, we look forward to discuss the weak force and how weak force is able to stabilize an element. See you in our next class, and have a nice time.